Okay, in this video, the objective is to be able to distinguish and find the probability of dependent and independent events, okay? And so basically this is somewhat similar to the counting principle, although even using the counting principle, you need to determine, is this a dependent event or an independent event? So let me give you a few examples of what we're talking about here. If I say, what's the probability here's my bag of dice. I have five green, 3 white, and 2 red. Okay, so 5 green, 3 white, 2 red. Okay, what was the probability that I pull out 2 green die? 2 green die. At random, I randomly pull out 2 green die. So I shake them all up. What would be the probability of me pulling out 2 green die? Well, there are 10 die to choose from, and there are 5 green. So the probability of me pulling out a green die in the first round is a 5 out of 10 probability. Now, I said I'm pulling it out at the same time. It's the same thing as if I were to pull it out one at a time and not replace it. That's the same effect or the same outcome. So the second one that I pull out, right? The second die that I pull out, if I pulled out one of the green ones the first time around, we're finding the probability that I do both. So we find the probability that the first one is green, and then we have to assume that the first one is green. In order for the second one, I only have, if one of them is gone, there's only 4 green die left, and then there's only if one of the green ones is gone again, there's only 9 die total left. So the probability of pulling out the green on the first one is 5 out of 10. Multiply that times the probability of pulling a green on the second one with the remaining 9 die, 4 of which are green, and the probability of pulling out 2 green die is 20 over 90, or we can simplify that to 2 out of 9 probability. Remember, probability can be written as a fraction, a decimal, or a percentage. Now, what if I said, if I change this, that would be, again, that is a dependent event because the second one is dependent on the first one. Okay, now, if I was to say, well, what would be the probability of me pulling out a green die, putting it back, shaking it up again, and then pulling out another green die? Well, that's a little different. That's an independent event. The second outcome doesn't affect the first. So the first time around, it's a 5 out of 10 chance. I put it back in there, and the second time around, it's a 5 out of 10 probability. See the glare right there. 5 out of 10. So then if we were to simplify this, we get 1/2 times 1/2 equals 1/4. There's a 1 in 4 chance of me being able to pull one out, put it back in, and then pull it back out. So this is an independent event. Okay, so the second one doesn't affect the first. And if you didn't catch it already, one of the big things to tell if it's a dependent event or an independent event is replacement. If you don't replace the item from the first event, then and you don't replace it, it's going to be a dependent event. It depends on what the second one, or third one, and so on depends on what the first one is. Let's give another example. Let's say I have a deck of cards, and I want to know what is the probability of pulling out, let's say, a jack on the first time, and then I put it back in, and then I pull out, let's say, an ace. Okay, so this time I'm replacing the jack first. So what's the probability replacing the card? Okay, so the probability of me taking a deck of cards, pulling out a jack the first time, well, there's 4 jacks in the deck, and there's 52 cards, so 4 out of 52, that simplifies to 1 out of 13 that I put the jack in. I put it back, and what's the probability of me now pulling out an ace? Well, there's 4 aces in the deck, and again, there's 52 cards in the deck. By the way, you should know that there's 52 cards in the standard deck. We're not counting jokers. So there's a 1 in 13 probability that I pull a jack out the first time, or you place it. There's a 1 in 13 probability that I pull out an ace. So there's a 1 in 169 probability that I can pull out a jack on the first time, put it back, and pull an ace in the second time. What if I don't replace it? What if I say, what's the probability of me choosing 2 cards, and one of them is a jack and one of them is an ace? Well, the probability of, now this is a little tricky, right? One of them is a jack and one of them is an ace. The probability of the first one being a jack or an ace is at 8, because there's 4 jacks and there's 4 aces. That's the 8 out of 52, which by the way simplifies to 2 over 13, right? And then I don't replace it, and then so what's the probability of the next one being a jack or an ace? Well, there's only 7 left of each out of the 52. So let's see if I can simplify this a little more. I said that this simplifies to 2 out of 13, I believe, and I think this 2 and this 52 can be 26 and 1, so I have 7 and whatever 13 times 26 is, using 338. Okay, and that cannot be simplified anymore. So I have a 7 out of 338 chance of getting a jack and an ace if I pull out 2 cards. Okay, so this is, and again, this one was with replacement, so that's independent, and this one was dependent because the second one depended on the first one. So again, it's basically the counting principle, but you find the probability of the first one, and then you need to see if especially if the bottom number changes for the second one before you multiply that out together and use the counting principle. So, well, like everything else, it requires practice, and you'll get the hang of it the more you do. But that's essentially dependent and independent events. See ya.